Hi guys, so it's weekend time here. I mean, it's Friday, I just finished work and went to the gym. This weekend, something different than the normal has happened. For the first time in months, I don't have something to work on for the mailman and the butler. If you follow my channel, you know that that's the project I'm working on. It's pretty close to completion, I'd say. But right now I'm waiting on some hardware. Basically, the problem was just sleep and wake up. Unfortunately, that transceiver I was using was not a good fit. Transceiver I was talking about. Regardless, I have been putting many ideas on a Notion board, and I'm gonna use one of them. I had like the best idea like 2 weeks ago, and I'm gonna use it. I will try to develop a minimum viable product this weekend. That is my main goal. I don't know if I'll be able to do it, but I will certainly try. Let's see how it goes. I gotta take off this puffer jacket. It's starting to get too warm. The ideas have to be have to be out in the wild, so we gotta do it. And whenever you have a good idea, just go for it. I mean, what else you have to lose, right? So yeah, let's do it. So, step one done. Now the plan is simple. I have cables. I have an ESP32, which I wanted to use a smaller one, but the headers are not soldered, so to decrease friction, I just went with what I have. I heavily encourage you to have some in stock, like a set of microcontrollers that you really know how to use. I have two right now, which I have more than 2 units of. These ESPW Room 32 somethings. I also have like the smaller version and USB-C for this ones. And I know how to use the ESP IDF. I don't use the Arduino. Please don't. I also have the STM8s that I sometimes show. I bought like 10 of them. I also have some Raspberry Pis. Pi 4, Pi 5. I should stock up on zeros. I only have one and it's the non-Wi-Fi version. I really like using Linux and it opens the door for many beautiful projects, but it's also more difficult because you gotta take into account that it's different to program for an RTOS than for Linux OS. And second part is this tiny board. I will only use one of them. This is a time of flight sensor. This one specifically has a matrix 8x8. There is a very popular one which is like just a normal IR sensor and functions more or less the same way. This one here, it can output a matrix of 4x4 and 8x8, which means you can detect like certain... Just watch my hand. You can detect this, 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 this. I think you got it. My brain is just not functioning in the same way that it started today. Not that I'm tired. I'm a bit tired. What's up, team? Saturday? So, from yesterday I did some things. It's still not fully functional, the device. I integrated the driver that I had before. It was easy because I had a Zephyr RTOS implementation, which I used also for the ESP32, but since I'm using the ESP IDF, it's just better. If you want to take advantage of your boards, I think Zephyr sometimes is not the way to go because it does not implement everything. I had issues with creating a hotspot from a time in the past with the ESP32, and if you do that in ESP IDF, it's like a 5-minute thing. So the plan for today is to get that to work. So as you can see by the hardware, I have one pin that's disconnected, and I'm sorry if you don't see it like too close. Let me see. Maybe like this works best. But yeah, every time I put that pin on, it turns on the device, the TOF sensor, and everything is going down. I lose signal from the ESP. This is also not 100% the same ESPs that I normally used. This one specifically, if you can see like this tiny little chip here, I should be highlighting it into post-production. That small chip is the sort of serial converter to USB. That's a different driver than the one I used before. Other than that, I don't really see the reason why things have been a bit different. For example, to flash the chip, I have to click on the boot button for a while it's trying to flash with the ESP IDF tooling, which is different than the normal. I don't really understand why, but for now it will suffice. So now what's the plan for today? As you can see by my beautiful whiteboard, I don't know, I don't even need to get off the ground now. This is the plan. This is what I see. Power enable and 3.3 volts. The ESP goes off, no idea why. These are the alternatives, connecting the pin directly to 3.3. And the other one is connecting it to an external power source. To be honest, I don't think that's the problem. I had 4 of these sensors connected to one ESP and I never ran into trouble, so I'll keep you posted, guys. See you in a bit. Oh yeah, I forgot. Why do I look Chinese? Sorry, I just look yellow and I made a joke. I'm a bad person. I forgot one thing. I also gotta record some things today. Let's look at the numbers. So these are the channel analytics. As you can see, this last short was like really poor performing. I don't know why. I think it looks great in my opinion in comparison to the previous ones. I really improved the quality, or I made an effort to. It has the same amount of likes as basically all the other shorts. That's why I don't really understand the poor performance. Basically, YouTube didn't send it to anyone. Could be because of the 1 month difference between both ones. But if you see the amount of likes, it's way better than the previous ones. So I don't really understand why YouTube is doing this to me. So we gotta do some shorts. So fast forwarding a few hours, it's around about midday and I have good news. As you can see, it's sending me data. It has some error because that's the real-time logic behind it. I'm sending data from one task that's retrieving all of this time of flight sensor data at 15 Hertz. So it's a lot of data because it's 64 pixels. It's not pixels, but it's areas, it's something like that. And I figured out the error. The power enable pin here of the time of flight sensor could not be connected to the ESP, at least not to a normal GPIO pin. I connected it directly to 3.3, which is good enough for my use case. And now, as you can see, I'm getting a lot of data. Next step is to process this data into something useful, maybe through a Python script, visualize it, and then also add some action to the Python script so that this translates into something, which is the whole goal of developing a product, is that you have an input, which is here, and now I gotta turn this into an output. Wish me luck! So, a bit of a good update. The software is running. As you can see, I got some... ChatGPT made it, not me. But as you can see, I get some data from it. And if I try to move the sensor, let me see if I can do it like on camera. Right now it's placed on my keyboard. And if I do something like this... that was a bit too much, but you can see like the alterations in red. It's got a bit of a delay, but I've basically been testing 2 alternatives. One was placing the sensor on the monitor. It doesn't work as well as placing it directly below the keyboard, because directly below the keyboard you have like, that's where your hands are and you don't want to take them out. Right now my plan then is to make the initial prototype and also decide the direction that I want the software to take. Because I can do this the easy route, which is deterministic and probably won't work too well for every single case. Or I can use machine learning. I know that the ESP is good enough for machine learning. It's gonna be difficult for taking data, but I think I can like generate some of it. Hopefully that works well. I don't know if I'll be able to generate it so easily, but I will definitely try. Regarding the hardware for the initial prototype, look at this. I have this ESP32C3 and the sensor can technically be cut off like that seam. I don't think you see it well, but I'm thinking putting this on a proto board or perf board or whatever you call them. Get rid of that. And also I can give some to my friends and they can give me data and feedback. Just a quick last update of the day. I've tried to solder the small ESP32. Did not work too well. I made a very small board which would have looked amazing. Look at it. So small and cute, but there is something there. I can't figure it out. Probably some soldering issue. It's got a little hard. So, I have actually a smaller one. I'm gonna put it here on my keyboard and I'm just gonna see how it goes. We'll do some progress on the machine learning part. So I want to generate data for this, for the data set, not create data. Because I don't want to have my hand like for an entire week of doing gestures. No, that's not ideal. So I'll just try to generate data. I'm pretty sure it's possible. I think it's gonna work well. Pretty confident. See you tomorrow. Hi again. Sunday end of afternoon because life got in the way. I have good news and bad news. Let's start with the bad. This thing here that I spent like how much time soldering doesn't work. So the little art, there's no love. Doesn't work well. I think it's something not only related to I2C because the I2C is definitely different. If I show like this board over here, I tried it and it's supposed to be the same thing, but the I2C was always giving me like a negative number for the distance, which is just not correct. So I went back to basics and the thing I did was this little guy over here. The main idea behind this thing here, let me point the camera at myself, is having the sensor pointed straight up so that I can use it like to hover and do swipes and gestures. I wanted to put it here, but it didn't work well. I couldn't get it just the way I wanted, so I used that. And by the way, this arrow is just to indicate this way up. I should not have made a prototyping board like that one that doesn't work so fast. And in a way, I kind of procrastinated because of it. But let me get here to the whiteboard. As you can see here, we have the matrix of 64 squares that the sensor outputs. You can see that the first idea I had was to use the relative distance between all points, which meant I would calculate the minimum between all of them and then clip the maximum distance to around 30 centimeters. It's more than enough. But the problem with this is that it's flawed because imagine you are looking straight up at the ceiling, so, or even imagine I was the sensor and I'm pointing to the whiteboard. You know what this would mean? All of these squares would be 0 because the relative distance would be 0 to all of them. And imagine now I move closer and closer. It's still 0. I know. But the plan remains the same. So the idea to generate the dataset, I've done something simple like hovering and no gesture, and I'll show you if that's working or not. Then I would basically train a machine learning model. In this case, I'm going for the SVM. In case you don't know how an SVM works, let's picture this gesture or no gesture example. Imagine you are in a two-dimensional space, which is definitely not the case with this because you have distances and you have the previous frames. Yeah, had to get the pen. Let's pretend I have another color. Oh goddamn. Let's draw something random like, can be something like this. So a line. I have some points here. Then I grab another color, which right here. I would have another color with X's. And you would divide this into hover, no, gesture. So imagine I get the frames from the TOF sensor, like from here, and this would mostly land in here, or it could land here. And then according to this line that you drew, by the way, in the most simple case, this line is just a mx plus b. This is just a linear regression that says above this line it's something, below this line is another. I'm gonna tell you another one that I know that's very easy, which is the k nearest neighbors. So imagine you have the same points and my point lands here. How would I know if this is a hover or a gesture, or a no gesture actually? I would basically calculate, and for the k nearest neighbors there's a k parameter. But yeah, this is a very simple one. There are others. Let's pretend it's 3 to make it easy. I have to choose the 3 nearest points to my data sample, and this is how I will figure out that this is a hover. The reason why sometimes people avoid the k nearest numbers is that you need all the points in your well, in the SVM you just really need this and then the inference, which is the act of calculating the result in your device. There is others like decision trees, something forests, which I'm not remembering the name. I honestly really like SVMs for this kind of purpose, so I'm tending to go to that. There's also neural networks, which is the thing that makes the headlines most often. Here's machine learning and AI in 5 seconds. For sure it's got some other complications, but this is the simplest terms. Of course, you cannot forget that the most important part of machine learning and AI is data. So in that regard, we have to jump to the computer. In regards to the generation of a data set, that's going At first, I don't know what's happening, but both ChatGPT and Claude went on a tangent and gave me like a gigantic Python script for this, and I was like, oh hell no. So I asked them like the smallest thing, and I tried to describe it just for these 2 gestures, and this is what we have. So we have a dataset generation, which generates a bunch of this data is basically an absolute distance between 0 and 30 centimeters. I gotta say that the hover is working alright. It's not perfect, but it's also mainly due to my prompts. So I can't blame the AI, I can blame myself for that. As you can see, I've already trained an SVM. I didn't put one like in the actual ESP, but that's a next step. And if this works, I know that the ESP is good enough for that. Mouse avoid. It's what I'm calling it right now, because this can avoid the mouse. It's basically saying no hover, and the confidence is just a value that's automatically in there. It's hard coded, I've checked it. But yeah, as you can see, every single square is a value, and the value is 300, which means 300 millimeters according to the scale, and it detects no hover. And this small number, the 5, it's a return value that I will want to use because it's very important. It just means that the value detected by the time of flight sensor for that square is alright. So now you will be able to see OBS because of the magic of editing, and I will put my hand here. It's already doing something, but my hand is pretty far away still. So now I'm gonna move my hand closer, and you're gonna watch it's got a delay, but as you can see, it detected the hover. It's not perfect yet. For example, if I stay with my hand here, I think it won't detect anything. Yeah. Now if I release my hand, it's gonna detect it. Or it should at least. Oh, it didn't. Yeah, there's definitely a lot of work to do, but like if I do something like this, it should detect it. Yeah, as you can see, it's not working too well. Now it detected. Okay. It's still got some work to do. Okay, that's it for the weekend. In my opinion, this project has the approval for myself. I will try it. I will do it. As soon as we go here to the little guy, mailman is still a work in progress, and I can do both. At first, let's try to finish the mailman. It looks really good, but yeah, these little things here really screwed me up because I wanted to use them, but that radio doesn't work too well. I'll make a short about it. It's unfortunate, but it's the way it is. I will keep you posted with updates from the mailman and the butler, and also for this little guy over here, which I think has loads of potential. Tell me what you think. Is this something that you will want to see more in the future? I'll for sure see the feedback, and let's see you next time. Peace out.